Okay, guys, welcome back to another stream. And today we are solving LeetCode contest 495, and we'll be coding live here. Starting with the first question because I'm quite late. The first matching character from both ends. So you are given a string s of length n, consisting of lowercase English characters, written the smallest index such that s of I is equals to s of I n minus I minus 1. Okay. So what it is trying to say is, okay, so let's go to the Python code. And here, if our input is A, B, C, A, C, B, D, then return the smallest index I such that S of I is equals to S of n minus I minus 1. Okay, so here our I is here, and let's say our J is here right now. Okay, we'll check if both of them are equal. No. Now, if they are equal, yeah. So it is a very easy question. We'll assign our I is equals to 0, and let's say according to the given question, we are assigning length here, and our J is pointing to n minus, no, mm, yeah, n minus I minus 1. We are assigning J here. So J will be pointing to the last index. Now, while I is less than equals to J, if uh if S of I equals to S of J, if S of I is equal to S of J, then what we'll do, we'll return I from here. Okay, and if not, then what we will do, we'll increase the I by 1 and J minus equals to 1, and we'll return minus 1. So will it work for each test cases? Let me see. Output is 1. Here also output is 1. Here as well the output is minus 1. Okay, let us submit this. I hope it won't. Yeah, it is working. Let's go towards the next question, and that is design event manager. So you are given an initial list of events which where event has a unique event ID and a priority. Each event has a unique ID, unique event ID, and we have a priority. Implement the event manager class, event manager news, event manager. Inside the manager with the given events where event size equal to I, update the priority event, and okay. So first of all, uh, we need to define the constructor which initializes the manager with the given events. Okay, so we'll write self dot events equals to events. This is the initialization step. Self dot events is equal to events. So we assigned here. Okay, now we have update priority. Update is the priority of the active event with ID event to new priority. Okay, so here what we will do, we will check self dot events of event ID. Okay, it is a list of listener. So we have to traverse and then update. So for uh, EID, comma PID, EID and PID P in self dot events and self dot events. So for each event ID and priority PR in self dot events, what we'll do, we'll try to search for that event first. So there are two methods of doing this. First, find the index at which it is found. So we'll try to give it -1, and we'll check um what to do now. For mm, 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 I in range self dot events, for each for index in events, if we'll check if uh, events of I, it means that event dot 0 equals to event ID. Okay, if events of I of 0 equal to event ID, then what we'll do, we'll events of I of 1 equals to new priority. That is, and that's it. And we'll continue from here. What we'll do, we'll break from here because we already assigned here. So this is assignment step. Assign new priority and then break from here. Okay. Now, okay, got it. So from here, it will assign the new event priority, found event with event ID. So this is the step where uh, we are able to find the given event ID and assign the priority. Now, let us go towards the poll highest. Removes and returns the event ID of the active event with highest priority. If multiple events with the same event, if there are no active. Okay, so first of all, I'll do return -1, and what I'll do, this is the, you know, this is like a priority queue. So what we'll do is we'll import heap queue from here, and what we'll do, what we will do here, we'll try to heapify. So heap queue dot heapify, what to heapify? Events. And I have to check whether how to heapify. List of list info file. The main issue I'm getting here is how to heapify based on the second. I mean, I'm confused in a syntax. So I'll heapify even from here. So this will, this will heapify the heapify, max heapify. So what we are doing here, we are assigning, we are creating a hash map of all the active events that are currently active, uh, mapping their EID with their priority. And then at the same time, we'll heapify. So it is heap push, heap push self dot heap, comma. So we are assigning here and then minus PR, comma, EID. In this way, we are able to create our heap at the same time of the initialization. Okay. So while updating the priority, what we'll do here, we'll try to do self dot active events, and then we have event ID, equals to new priority, and then heap q dot heap push self dot heap, comma, new priority, comma, event ID. So what we are doing here is we just post another priority. Got it. Next is poll highest. So inside the poll highest, what we'll do is while self dot pq, we will extract pr and eid from heap q dot heap pop of self dot heap. So this will give us priority in with negative value, so we'll assign it to a positive value. And then what we'll do is we'll have to delete it. In this way, we have already deleted this element from the priority queue. Now, since we were pushing here one more time, so we'll have to check for the same key. We'll have to check. So if eid in self dot uh, active and self dot active of eid equals to pr, then what to do is delete self dot active eid, return eid. Got it. So here what we are trying to do is uh, when we were trying to update the priority here, so we directly updated the priority inside the hash map we created, and after that we were trying to push the new priority again with that event id. So what is happening is, if the priority is smaller or it has a larger priority, then it will float on the top side of the priority queue. So while deleting, what we are doing is this will delete the top key. This will delete the maximum key from the heap, and from here we'll try to assign priority, and then we'll check if eid and self dot, if there is an id exist inside this, then we'll delete it. So this is somewhat lazy deletion. So let me try to run this, and the output is null to null 59. Nice. And after that we have one more thing, that is null 74 minus 1. Nice. So now let's submit this. Yeah, so this was our solution. Okay, GG. Nice. So let's go to the next question. And the next question is, oh nice, it is a hard question. Sum of sortable integers. So you are given an integer array nums of length n. An integer k is called sortable. An integer k is called sortable if k divides n, and you can sort nums in non-decreasing order by sequentially performing the following steps. Partition nums into consecutive subarray of length k, cyclically rotate each subarray independently, and number of times, any number of times to the left or to the right. Return an integer denoting the sum of all possible sort integer k. A subarray is a contiguous non-empty sequence of elements with an array. Okay. Okie dokie. गौरव, तीसरा, तीसरा हुआ खतरनाक है। तीसरा चालू कर रहा हूँ, देख रहा था कितनी वॉचिंग आ रही। तीसरा, तीसरा हुआ खतरनाक है। तीसरा चालू कर, देख रहा था कितनी वॉचिंग आ रही। Okay, nice. Let's go towards this third question, and I would like to check the fourth question first. Both are hard, and okay, this is the graph question. So incremental even weighted cycle queries. You are given a positive integer n. There is an undirected graph with n nodes labeled from 0 to n minus 1. Initially, the graph has no edges. Okay. You are given a 2D integer array edges where edges of I is equal to u, v, and w represent an edge between nodes I, u, and weight. Okay. The weight wi is either 0 or 1. Process the edges in a given order. For each edge, add it to the graph only if, after adding it, the sum of the weights of the edges in every cycle is in the resulting graph is even. Okay, return an integer denoting the number of edges that are successfully added. Okay, so I have to try run it on my tablet. This is a very good question, by the way. I'll need a data cable. Okie dokie. Now our tab is also connected. Oh, LeetCode. It is lagging. I don't know what's going on. Show, yeah, show what's going on. Yeah. So In this question, let me read the question first. In this question, we are given with some edges that are 0 to 1 with weight 1, and 1 to 2 with weight 1, 0 to 2 with weight 1, and number of edges are 3. So what we have to do is, while adding an edge, what we have to check, um, the sum of the weights of the edges in every cycle in the resulting graph is even. Okay. So return an integer during number of edges. Okay, so we'll try to add this edge first. So with 0, we'll add 1, and this is 1. Okay. Currently, there is no cycle formed. Now we'll go for this edge, and this edge will say that add an edge from 1 to 2 with a weight 1. Right now, there is no cycle, but when we're trying to add this, if we're trying to add this, then the weight will be 3, because 1 plus 1 plus 1 is equals to, that is 3, and 3 is an odd number. And in the given condition, it is stated that only add if and only if a cycle formed is odd cycle, odd length cycle. Okay, so how can we solve this question? How can we solve this question? Nice. First of all, we'll have to check for the cycle detection algorithm. And the cycle detection algorithm, we can detect a cycle using disjoint set. Disjoint set is one of the method for detecting cycle. And the another one is just by, since it is an undirected graph, we'll apply BFS. We'll apply BFS, and it is if a node which is already visited, if it's occurred, then we'll say that it has a cycle. But the best way here is Krishkal's algorithm with the disjoint set union. So what we'll do is, we'll first sort all the edges. We'll first sort all the edges. Should we sort or not? I think we should not sort, because we're not trying to find MST here. We are not trying to find NST here. So there is no criteria for minimum. There is no criteria for minimum, but yeah. So we have nodes from 0, 1, and 2. We have 3 nodes. Let us try to apply Krishkal's algorithm, or let us try to build this join set. Disjoint set. So when we first incurred with this edge, when we first incurred this was at 0, 1, and 1, we'll check if there is no cycle exists, then we'll attach this to 1 with a weight 1. Okay, so currently our weight is 1. Now for the second edge, we'll see if we're able to attach it. Yeah, we can attach it because there is no cycle found right now. For so with the path compression, this will be attached here. This will be attached here, directly here. And for the third edge, if we check that if we check that the uh, cycle exists, yeah, cycle exists, And if current weight is percentile 2 is not equals to 1, then we'll not add that edge. That's the algorithm. So first we'll try to implement disjoint set, and then we'll go for the next. Hey, yeah, let me keep it aside. Easy peasy question. Of course it is hard, but I am able to solve it. So we'll define a class first, disjoint set, disjoint set union, and in this class we'll have self def init, which has self comma number of edges. So what it will do, it will define it will define parent as a list of range of n, because initially we assign, I'm not teaching here disjoint set data structure. So this is a init function. This is a constructor in which we have a parent having storing a list of n, and we'll define a find function which contains self and x. And if self dot parent of x is not equals to x, then we'll lose self dot parent of x is equals to self dot find of self dot parent of x. So this is the path compression step. Next is we'll return from here self dot parent of x. So this is our find function. Let us write this function self of union of self of x comma y. So we'll try to union these two. We'll find px is equals to self dot find of x, and then py equals to self of find of y. So here we'll get both the parents, and if px is not equals to py, then self dot parent of py equals to px. But here one more thing we'll try to implement is self dot size, that is 1 star n, and here we'll check if px is equals to py, then return from here else attach smaller to bigger. So if self dot size of px is less than equals to self dot size of py. Okay, so what we'll do, we'll try to attach px comma py equals to py comma px. Okay, so this is our disjoint set. Is it correct or not? Let me check. Attach smaller to become. If the px is smaller, then what we'll do, we'll okay, we'll swap the parents, and then after swapping the parents, okay, nice. So our DSU is ready. Now let us go for the main logic. In this, what we are trying to do here is, for each edge, what we need to do is we need to check if there is no cycle formed till now. If there is no cycle formed till now, add that edge and its weight. If not, if cycle exists, then check if the cycle, mm, if the cycle length is even, then add edge. Otherwise, don't add. Okay, very easy algorithm. So we'll define a data structure, ds equals to ds with n number of nodes from 0 to n minus 1. It is 0 to n minus 1, yeah. So we'll define a data structure 0 to n minus 1, and then we'll go for each edge. So edge is a list of list 2D array. So for each u comma v comma w in edges, for each u comma v comma w in edges, and we will have a global weight sum, or we'll say weight sum, that is equals to 0 right now. And for each u, v, and w, sorry, for each u, v, and w, we'll check if ds dot find of u, if there is no cycle exists, df does find dot ds dot find of u and v. If there is no cycle exists, then what to do is ds dot union of u comma v, attach them and add weight to the weight sum w. Okay, and if this is not the case, it means no cycle exists. There is, it means number count is equals to 0. We'll increase the count by 1. We'll return count from here. It is a very nice question, yeah. It is very nice question. So ds dot find union and ds dot find v. There is no cycle exists. So it means cycle exists. So if cycle exists, but the current weight sum plus the current weight percentile 2 equal to 0, it means after adding this, after cycle exists, and after adding this it is a even, then what we'll do, if it is a even, we'll union the edge u comma v, and we'll update the weight, okay. We'll union them and we'll update the weight. Otherwise, we won't do anything. So otherwise, we won't be adding any kind of edges. So let me check if it's working. It has some errors. DS is not defined. Okay, it is an okay. I termed as DSU, or I can remove it from here. Let me check. Output is 2 here, and the output is 3 here. Able to do it. Yay. I'm able to do it. I'm able to solve the hard questions. Yeah. So all edges are distinct. Nice, 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 nice. So I am able to figure out this question. Let me check before submission. Is it working fine or not? Here we swap the parents so that PX always PX is always a parent. Swap to swap so that PX becomes greater. Okay, and then we'll assign here. Nice, nice, nice. Let's try to submit this question. It has a wrong answer. Nice. 288 test cases passed. Nice, nice, nice. So let me check why it is not working. I was able to figure out the question, but let me check. Let me check. Oh, I think I got a penalty as well. So for edges 0, comma 1, comma 0, 1, comma 2, comma 0, 2, comma 3, comma 1, 0, comma 2, comma 0, 0, comma 3, comma 0, and 1, comma 3, comma 0. So we'll have an edge 0, 1 here. So for 0, 1, the weight count is 0 right now, and weight is also 0 right now. Can we attach it? Yeah, why not? Okay. Next, can we attach it? Yeah, why not? Next, can we attach it? Yeah, why not? Count will be 1, 2, and 3. Count will be 3, and the weight is 1 here. 0, 0, 1. Next, 0, 2. Can we attach it? But it will say that, yeah, there's a cycle exist. It will exist a cycle, but see the weight, we can add it because it's not. We cannot add it. Why? I just misjudged the condition. We cannot add it because because the weight is odd. Okay, so we won't be adding this edge. Next is we'll go to the next edge. We'll check 0, comma 3. Can we add? No, we cannot add because the weight is 1. Now we'll go here. Can we add 1, comma 3? No, 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 no. We cannot add. So here the answer is answer coming is 3. But we can add 4. Why? How can we add 4? 0, 1, 2, 3. Okay, h from 0 to 1, 1 to 2, 2 to 3. Nice. Try to add, if I'm skipping this now. Okay. Got it. I have to sort it based on the third element. I have to sort it. So sort edges. No, edges dot sort. Edges dot sort, and key will be lambda x and x of 0 1 2. So will it sort? Nice. So after adding this line, let me use this test case and then we'll try to run it. Are we getting 4? Can't we add our custom test case here? Output expected is 5 here. Okay, so I'm getting a little changes here. Parity is equals to 0 star n. And while finding this, I'll find for root equals to self dot find self dot parent of x. And then, okay, so it will change the priority from 0 to 1 and 1 to 0, because if 0 0, it will give us 1. 1 0, it will give us. कि दसो यार दिए दसो यार स्ट्रीमिंग तो बंद कर दो।